Yes, what is the meaning of float star PTR? It means PTR is a pointer variable which is used to store the address of another float variable. But when we declare a pointer variable like void star PTR, that means PTR is a pointer variable which may store the address of any type of variable. That I already discussed with you earlier in my lecture. And there are some limitations of this void pointer, which is written in the last point of this slide. As because void pointer is stored temporarily stored the address of any type of variable, and it is a typeless pointer. That's why compiler has no information that how many bytes of data it will retrieve from the memory starting from the stored address. That's why indirection operator cannot be used on the void pointer. That is the limitation of using void pointer. Indirection operator, we all know, that is star, value of. Address of operator is ampersand. Indirection operator is star. Star cannot be used on the void pointer. Why? Because pointer, the void pointer is used to temporarily store address of any type variable, and void pointer is basically typeless pointer because it is pointing, it can store the address of any type of variable. So that's why it is a typeless pointer, you can say. And the compiler has no information that how many bytes of data it will retrieve, because in case of int star PTR, it knows the size of integer is 4 bytes. So the pointer needs to retrieve 4 bytes data from the memory. Fine. In case of character pointer, compiler understood it requires 1 byte data to read, because the data type of the pointer is character, as because this pointer is storing the address of another character variable. But when it declared as a void pointer, it has no idea that how many bytes of data needs to retrieve for indirection operator to return back the answer. So that's why indirection operator cannot be used on the void pointer, and that is the limitation of void pointer. So this topic is basically required today. That's why I am just recapping this topic. Many of you have already gone through my lectures in the lectures about void pointer. I have discussed detail over there. So now I am coming back to today's topic, that is dynamic memory allocation. So before starting the topic, let me explain why this dynamic memory allocation is required. So far we declared variables, different types of variables in our program, like int star, integer variable, float variable, character variable. Integer takes 4 bytes, float also takes 4 bytes, character takes 1 bytes. That we all know. Fine. My question is, when this memory allocation has been done, integer takes 4 bytes, float takes 4 bytes, character is taking 1 byte. If I declare a variable of this int, float, rather if we declare an array variable int ARR of size 10, so that means ARR is an array of type integer, size 10, maximum size 10. Each integer takes 4 bytes. So that means the array memory allocation is for the array is 10 into 4, that is 40 bytes. That we know. But my next question is, when this memory allocation has been done? This memory allocation is done at the time of program compilation so far. The program that we have written so far, in all the cases, the declared variables. For the declared variables, the memory allocation process done at the time of program compilation. Fine. But today we are going to learn the memory allocation process at the runtime. What is the meaning of runtime? Means when the program is going to execute, when the program is running, at that time we are going to allocate memory for the variables. Is it advantageous? Answer is definitely yes. Why? Look, if we declare a variable, rather array variable, ARR of integer size 10, what is the limitations of array variable? If we want to store 8 value inside an array of size 10, so 2 spaces are basically wastage. No need of uses these 2 spaces. On the other hand, if I want to store more than 10 value in the same array, we can't store. Why? Because the size declared for the array variable is 10. So the array variable, if I declared the size of array is 10, and if you store only 8 in the array, the memory spaces for 2 integers are basically wastage. On the other hand, for the same array, if you want to store more than 10 data, you can't store. Because you declared the memory allocation, you declared the size of an array is 10, and the memory allocation for 10 integer has been done at the time of compilation. So when you are executing the program, you cannot store more than 10 integer in that array. Similarly, at the time of execution, if you store 8 integers, that means 2 spaces are basically wastage. So dynamic memory allocation is the solution of that problem. What it does, it allocates the memory when the program executes. So definitely it is advantageous for using. For the dynamic memory allocation purpose, we have go through 4 functions. Number 1 is malloc, MALLOC. Second function is calloc, CALLOC. Third function is free, and fourth function is realloc. We have to run through these 4 functions, and these 4 functions are required to do the dynamic memory allocation. So let me share the screen with you to show the syntax of the malloc calloc functions. First, let me share the PPT. Yes. This is the syntax of malloc function. Malloc function is basically used to allocate memory at the runtime, fine, when the program executes. What is the syntax of this malloc function? The syntax of this malloc function is malloc it takes only one parameter. It takes only one parameter, that is total bytes for memory allocation needs to allocate memory. That means amount of the total bytes. Again, I am repeating, malloc function takes only one parameter. That parameter is basically the amount of bytes memory block is to be dynamically allocated. Amount of bytes memory blocks is to be dynamically allocated. That means how many bytes you want to allocate memory. That many bytes you have to pass as a parameter to the malloc function. Malloc function takes only one parameter. Here in this slide, what it is written? It is written, just look the right part of the malloc function. Look about the parameter part. This is the parameter part of the malloc function. It is malloc 5 into size of int. Try to understand. Size of int, size of is an operator which basically returns the amount of byte the integer data type takes. So it will return definitely 4. It will return definitely 4. Fine. So if it returns 4, so 5 into 4, how many bytes? Total 20 bytes. So we are passing 20 bytes as a parameter to malloc function. Fine. In place of 5, if we write n, so at the time of program execution, malloc takes n into size of int. Malloc takes n into size of int. So what is the meaning of that? That means we are going to allocate memory for n integers. Here the example says we are going to allocate memory for 5 integers, but instead of 5, we can take, whether we can set it as n. That n is taken from user. So that means depending upon our requirement, we can allocate memory through this malloc function. So malloc function is used to dynamically allocate memory. It takes one parameter. What is the meaning of that parameter? The meaning of that parameter is the amount of bytes memory block needs to be dynamically allocated. Amount of bytes memory block needs to be dynamically allocated. That much amount of byte we have to pass as a parameter of malloc function. Next part of the malloc function. If it successfully allocates memory, it returns a void pointer. What is the meaning of that? The meaning of that is the malloc function returns a pointer. What is meaning of that pointer? The meaning of that pointer is definitely the successful allocated memory. If the memory allocation is successful, then definitely it returns the starting address of that memory chunk. Suppose here in this example, we are allocating memory for 5 integers. That's why we have passed the parameter 5 into size of int. Then the next part is If the memory allocation has been done successfully, it will return a void pointer, and the void pointer, what it stores, it returns void pointer means pointer is a variable which is uh, nothing but can store the address of another variable. So when it returns a pointer, that means basically it returns an address that we all know. Returns pointer means basically returning an address. Address of what? Here, address of the starting point of this 20 bytes. It allocates memory 20 bytes. Just look this example. That's that part. This part. It allocates memory 20 bytes, and the starting address of this 20 bytes is returned by the function malloc. But what it returns? It returns as a void pointer. What is the limitation of void pointer just discussed today? The limitations of void pointer is we cannot get the value of this void pointer because indirection operator cannot be used on that pointer. If we write star of that pointer, we cannot get the value because indirection operator cannot be used. So that's why we need a typecasting. That's why we require a typecasting. And this is the typecasting part. It returns void pointer. Again, I am telling you, it returns void pointer, and that pointer needs to be typecast. Why it needs to be typecast? Because the void pointer on void pointer, we cannot use the indirection operator. We cannot get value of that particular address. So that's why we need to typecast it to the data type that we consider. Here we consider the data type of integer. We are going to allocate memory for 5 integers. That's why we are typecasting this void pointer to integer pointer, and that typecasted pointer is stored inside PTR. So what PTR means? It is nothing but the starting address of the memory, rather allocated memory, done by the malloc function. I hope this much is clear to you. Anybody have confusion regarding malloc function? If you have, you may ask the question. Unmute yourself and ask the question. No, no question is there. So, okay, fine. So we are trying to implement, this malloc functions in our program. Let me share the program screen with you. I hope the screen is visible to you. Fine. First, let me save the program. So I'm giving the name PTR26.c. Fine. So to use those functions, rather malloc, calloc, free, this type of function, those are used for the dynamically memory allocation. We have to include stdlib.h, stdlib.h. Fine. So thing is that, say we are going to take n integers, we don't know the value of n, we are going to allocate memory for n integers at the runtime through using this malloc function. So we have to consider a pointer, just like our previous example, just like our previous slide, in star p. So p equal to, before writing p equal to, we have to take input from user, that is printf /n, enter the number of integers. And now scanf %d, comma %n. Fine. Then in the very next line, what I am writing, p equal to int star, not to typecast, malloc, function malloc, n into size of int. So malloc function here allocating memory for n integers. If the memory allocation has been done successfully, then it returns a void pointer, and basically that void pointer stores the starting address, rather at the starting address of the memory chunk, as because indirection operator cannot be used on void pointer, so it needs to be typecast, and we have typecasted it to an integer pointer, as because we are going to allocate memory for n integers. If we allocate memory for n number of floats, so in that case definitely we need to typecast it as a float pointer. Nice. Now the next checking, normally this part will never execute, but still we have to write this. If the ptr value, rather p I have considered, not ptr, if the p value is null, we know what is the meaning of p is null. We already discussed about null pointer. So if the p value is null, then what is the conclusion? The conclusion is memory allocation failed. So we need to check this when we are doing dynamically memory allocation. Normally this part will never be executed, because if memory allocation failed, this case normally not happens, because we have enough amount of memory in our machine, rather in our PCs. So that's why memory allocation failed, this part normally doesn't occur. Still we have to keep this checking. But another thing that I must have to mention over here, that at the time of discussion of pointers, I mentioned that relational operator can be used with pointer variable. I haven't given any example at that time. So this is another example of using relational operator with pointer variable. Look, double equal to we have used with a pointer variable for the purpose of checking whether p value is null or not. If p value is null, that means memory allocation is not successful. Memory allocation failed. Then the next part. What is the next part? Memory allocation successful. Successfully allocated memory for n integers. That means 20 bytes. Fine. So let me check the value for those. Initially we have allocated n integers. If the else part is executed successfully, memory allocation has been done. So now we are going to check the value of that n integers. Look, for I equal to 0, I less than n, I plus plus, I'm going to check the address or rather value of, not address of, that n integers initially. I haven't assigned any value so far, just memory allocation has been done. I want to see whether any data, rather any value has been initialized for that memory, or is it giving us the garbage value. So that's why we are just checking what is the value right now after initialization of that memory spaces. So the value of this is, how we can access the value, definitely star of p plus I. Equal to %d, comma, star of ptr plus I. Is this clear? I hope. This star of ptr plus I, is this clear to you or have any confusion? So let me check the output of this program. I hope output state is visible to you. So I'm giving that 4 integers, say. Look, this is giving 44831744. Sometimes is giving 0. Sometimes is giving garbage value. Actually, these are all garbage. So the conclusion is, when we are doing the memory allocation by using malloc function, it do not initialize any value to the allocated memory. So initially, if we try to show the value of that allocated memory space, we will get some garbage values. So these all are garbage values. 0 is also garbage here. 0 is not initialized. 0 will be treated as garbage here. So we are getting the garbage values of those locations. We are allocated the memory space for 4 integers only. So I hope you understood what is the requirement of dynamic memory allocation. Why we dynamically allocate the memory? Because if we allocate the memory dynamically, there is no wastage of spaces and there is no requirement of extra spaces at the runtime. We can allocate memory as per our requirement of the program. That's why we will take help of the dynamic memory allocation in our program. So that is our basic objective of using this dynamic memory allocation. So next part, definitely we try to assign the value, rather we are taking input from the user for those 4 integers, or rather n integers. So just use scanf over here, and as because we were using scanf, so definitely we have to pass the address. So as because, no need to write this much, no need to give star also. You have to pass only the address, and after that we will just print the value that I have taken as the input from the user. Let me check the program, output of this program. Initially garbage. Look, now I've given the value 11, 22, 33, 44, 55, and this value gets assigned to that allocated memory spaces. So as per our earlier knowledge, we can interpret this thing as PTR I. That is the same thing. If we write PTR I in place of star P plus I, not PTR I, it is again PI. So if I write PI in place of star P plus I, it will give us the same result, because we know what is the meaning of P plus I, and that is equivalent to PI. So that's all for the malloc function. And when the task is completed that we want to do, here we are just taking input from user and just printing those values and as the output. So after doing our task, after completion of our task, we have to reallocate. We have to delete that memory space. So to do this, to do that, we have to call the free function. So what is the task of free function? Free function is basically used to deallocate the memory. That is done by the function calloc, malloc, or realloc at the runtime. So keep it in mind, we have to free. If you not freed it, that's just the previous cases. Before writing free, we have already executed our program. But if we not write the free, automatically the memory gets deallocated. Fine. But explicitly you need to mention this. You need to deallocate the memory. So that's why you have to call the free function, and what it takes, the function takes only one parameter. Free function takes only one parameter, not PTR. Again, I am writing. It takes only one parameter, that is the pointer, which pointer is used for the purpose of memory allocation. Here P is used. P is used for the purpose of memory allocation. So that's why we need to pass P to the free function for deallocation of the memory. So that is the function of free. So we came to know how we can allocate memory using calloc function, how we can use those memory spaces, and finally we have to free those, rather we have to deallocate those memory space. So I hope this much is clear to you. Any confusion? If you have any doubt, you may ask the question up to this. Do you have any doubt up to this? Malloc function, why ampersand is not used? Where? In scanf function. So actually this thing we have already discussed in the topic pointer. So what is the meaning of this ampersand variable name? The ampersand variable name means we are passing the address of that variable to the scanf function so that we can take input for that variable. We are passing the address. So when I'm using the pointer variable, what is the meaning of the pointer variable? What definition says? Pointer variable is a variable which can store the address of another variable. So pointer variable itself is a variable which is basically storing the address. So that's why when we are writing pointer variable as a scanf parameter, definitely we will not write ampersand because the variable itself is storing the address. That's why we have not written any pointer, rather any ampersand over there. That's why we have not written any pointer, rather any ampersand over there. Any question up to this much? बोलो क्यों कुछ बोलते चाहिए बोलो. No. So we are moving to the next part, that is calloc function. So again, coming back to the program, let me share the program screen with you. Then later on I will discuss about the PowerPoint screens. Yes. So we have allocated memory for n integers using malloc function. So if I use the calloc function, just instead of this line, I'm commenting this part, and instead of this, I'm using calloc. When I am writing calloc function, the calloc function takes 2 parameters instead of 1. Malloc function takes 1 parameter. Calloc function takes 2 parameters. What is the first parameter? How many number of integer or float or character for which we are going to allocate memory? That is n. If we are going to allocate memory for n integers or n float or n character, so you have to pass n as a first parameter. And what is the second parameter? The second parameter is size of each. So what is the difference between malloc and calloc regarding the parameters? In the calloc function, it takes only 1 parameter, that is total amount of bytes needs to allocate. In case of calloc function, we have to pass 2 parameters, that is first one is the number of integers, rather for how many numbers we are going to allocate memory, that is the first one, and second parameter is the size of each. So here we are going to allocate memory for n integers, that's why as a first parameter we are passing n, fine, and the second parameter we are passing size of int. And similar to malloc function, in the calloc function also, if the memory allocation has been done successfully, then it will return a void pointer. Once again, same thing like malloc, calloc function also will return a void pointer if it can successfully allocate memory. If it cannot, then definitely the value of p will be null. And as because it returns a void pointer, so we need to typecast as because indirection operator is not working on the void pointer. So I need to typecast it according to the data type of the pointer variable, rather according to the data type for which we are going to allocate memory. Here we are going to allocate memory for integer, so that's why we have typecasted it to the int star, rather integer pointer. So if p is null, memory allocation failed. What is the next part of our program? We checked the initial value of the allocated memory space. The rest of the part we had just commented for timing. Let me check the initial value of these allocated memory spaces. Let me share the screen with you. Number of integers 5. Look, all the value we are getting is 0. So this is another difference between calloc and malloc. When the calloc function allocates memory, it initialized value 0 to all the memory spaces, rather for all the integers, all the floats, all the characters for which you are going to allocate memory. It depends upon the user. Initial value is 0. But when earlier we have seen, when we used malloc function for the purpose of allocation of memory, for the malloc function of the purpose of allocation of the memory, it returns garbage. It returns garbage. So that is one more basic difference between calloc and malloc. The rest of the part will give you the same result. Let me uncomment that part. That taking input for n and just showing the result of this n values. Again, I am trying to compile and execute it. Five integers, initial value 0. Now I'm giving input. It is showing the inputted value that I have given. Fine. And similarly as before, I've used the free function. Line number 23, I have used the free function for the purpose of deallocation. Deallocated the memory space that we have done by using function calloc. So that's all for the calloc function. It's almost similar to the malloc, except two things. One is the number of parameters, and the calloc function, in the malloc function we have to pass the total bytes as a parameter. In case of calloc function, we have to pass number of elements for which we are going to allocate memory, and the second parameter is size of each element. And the second difference, that is initialized with garbage, that is no value will be initialized when the memory allocation is done by using malloc. But when we are using calloc, it is initialized with the value 0 that we have shown already. And one more difference is here that we can explain with the PPT slides. So I hope this much is clear to you. Again, going back to the PPT slide. If you have any doubt, you may ask. Unmute yourself and you may ask. The convention is you must have to use free function if you allocated memory by using any of those functions like calloc, malloc that we are using normally for the memory allocation purposes, dynamic memory allocation purposes. At the runtime, we are allocating the memory. Okay, moving to the slide. So this slide are already explained with you, that is malloc function. This is the slide for the calloc function that I just discussed. It takes two parameters, that much is clear for us. It initializes 0, that much is also clear for us. Any more differences that you can visualize from this slide? Look, this slide and this slide. The difference is when we are using the malloc function, the memory is allocated as a chunk. Look, but when we are using the calloc function, the memory allocation is done for each and every element separately. That's why it takes two parameters. First one is the number of element and second one is the size of each. But here the memory allocation is done for total 20 bytes. 5 into 4, total 20 bytes. But in this case, each are taking 4 bytes. Each memory allocation has been done separate manner. So actually the full form of calloc is contiguous allocation. Calloc, contiguous allocation. And malloc is memory allocation. Malloc is memory allocation and calloc is contiguous allocation. So each and every element memory allocations can be done by using calloc, but in case of malloc, the memory allocation has been done as a chunk. Total 20 bytes of memory has been allocated. Fine, but here 4 bytes each. Such type of elements, 5 blocks of 4 bytes each, it's dynamically allocated to PTR. Look, it's already mentioned. 5 blocks of 4 bytes each is dynamically allocated to PTR. And here, look, a large 20 bytes memory block is dynamically allocated to PTR. That is the different type of allocation is performed by using this malloc and calloc function that we have done so far. And the next slide is the free, already discussed. It is the memory allocation is done by the calloc function, so that's why 5 blocks of 4 bytes each is dynamically allocated. PTR is pointing. So total 20 bytes of memory. When we are calling this PTR, rather we are passing this PTR to the free function, free PTR, look, it's a recycle bin. The memory of PTR is get released. It's deallocated. Fine. So that is the function of free. Okay, fine. So if you have any doubt, you may ask up to this. Otherwise, I will stop for today's class. Next class, we'll discuss the topic realloc function, and we'll implement different programs using this dynamic memory allocation function.